This is 6.8 and 6.9 put together. So we're going to start off with density. The density of a material is equal to its mass divided by its volume. It's the DMV formula, Department of Motor Vehicles. So in another form, we could multiply by V, and we get mass is equal to density times volume. Or I could multiply by V and divide by D, and I get volume is equal to mass divided by density. Those are the three versions of this formula. And then we just use that to answer each of these questions. An object has a density of 52 kilograms per meter cubed and a volume of 65 meter cubed. What is the mass? So if we look over here, we want the mass formula, which is this one. So mass is equal to 52 times 65, and whatever that gives you. Now, do you have to memorize all of these formulas? No. So if I want mass, what is mass going to be in this problem? It's going to be in meters cubed. Okay? And then my density is 52 kilograms for every cubic meter, and my volume is 65 meters cubed, and I want my answer to be in a volume. So I need volume on top. So 65 meters cubed, and then I'm going to times that by this value, but I need the meters cubed to cancel. So if I times this by 52 kilograms for every cubic meter, will meters cancel? Meters cubed cancel, yes. So this cancels that. What am I left with? Oh, sorry, nobody mentioned that. Mass is going to be in kilograms. That was dumb of me. So 52 kilograms times 65 is going to be your answer. So go ahead and memorize the formulas if you want, but if you just pay attention to the units, you should be able to figure out exactly what you need to do. All right, for the next one, volume. So volume is in meters cubed. I have a density of 18 kilograms for every cubic meter, and I have a mass of 450 kilograms. And I want my answers to be in meters cubed, which is this one. Notice that's on the bottom. So in any unit, you can flip that unit upside down without changing anything. So 1 meter cubed over 18 kilograms. And I did that because I want my answer in meters cubed. Now I need to times that by this value, but I need to multiply it in such a way that kilograms will cancel. So I put 450 kilograms on top. Kilograms cancel kilograms, and my answer is just 450 divided by 18, and that will be its volume. All right. Okay, here we have a rectangle. In 2019, there were 1,170 people per square kilometer living in the city. What was the population in 2009? So we want the total population, which is going to be in people. Okay. We also know that this is 30 kilometers by 25 kilometers. So the area of that is going to be 25 kilometers times 30 kilometers. And what would 30 quarters be? $7.50. So 750 kilometers squared, I think. Yeah. All right. So that is the area of this. I want my answer to be in people. So I'm going to use this term and keep people on top. So 1170 people for every kilometer squared. I need to use this number, and I need to get rid of kilometers squared. So I'll put it on top. 750 kilometers squared. Area cancels area. And I get 1170 times 750, which is 8,775,000 people. Wait, is that right? No, 877,500 people. Okay. All right. Density is 21.6 kilograms per meter squared. What is the mass? Well, mass is going to be in kilograms. So I need to find the volume of this, which is 6 meters times 6 meters times 6 meters, which is 216 meters cubed. Okay. I want my answer to be in kilograms. So I use 21.6 kilograms per cubic meter, and I times that by 216 meters cubed. Meters cubed cancel. 216 times 216 is, it's going to weigh 4,665.6 kilograms. All right, identifying similar solids. Okay. In order for something to be similar, the one dimensions, every dimension has to be proportional. So this has a radius of 9, and this is a length of 36. So 36 divided by 9 is 4. This has a radius of 7 and a height of 28. 28 divided by 4 equals, or oh boy, 28 divided by 7 is 4. So are those similar? Yes. The x direction and the y direction are proportional. So, oh, we also have to check the z direction. So we got to check this direction. And yes, that's going to be proportional. Actually, let's do it the other way. So this is 9, this is 7, 28. So the x direction is 9 over 7, this one divided by this one. The z direction is 9 over 7. And the y direction is 36 over 28. And that simplifies down to 9 over 7. So I check the x, I check the y, I check the z. They're all proportional. So yes, these are proportional. What is the proportionality constant? 9 divided by 7 is 1.28. And then it keeps going. Okay. So what about their volumes? So this side is 1.28 times 7. What about the volume? Well, the volume uses all three directions. So the x is 1.28, the y is 1.28, and the z is also 1.28. So the ratio of the volumes is 1.28 to the third. Okay. All right, let's check proportionality on the second one. So 6 divided by 9 is 2/3. 2 divided by 3 is 2/3. 8 divided by 12 is 2/3. Are they similar? Yes. What is the scale factor? 2/3. Oh, which one does it want us to compare? Give the scale factor of 1 to 2. So I got it backwards. So it wants to know if we go in this direction, what is the scale factor? We're going from small to big. So the scale factor is going to be 3/2, which means the scale factor of the original one was 7/9. Okay. So if we go in this direction, we're going to divide 12 over 15. So 12 over 15 equals 3/5. And this is 7, and this is 3. So 3 divided by 7 is not equal to 3/5. So those are not similar. Okay. So here we have the density is 18.8 grams per cubic centimeter. And we need the volume of this figure. So the radius is 3 centimeters. The area of that is pi times 3 squared. Okay. So that is 9 pi centimeters squared. And then I need to times that by the height, which is 9 centimeters squared. There's 9 centimeters. So the volume of that figure is 81 pi centimeters cubed. And I'm looking for the mass of the object, which will be in grams. So I need to times this by that in such a way that centimeters cubed cancels. So 81 pi centimeters cubed. Volume cancels volume. And the area is going to be the mass is going to be 18.8 times 81 pi. All right. Okay. A designer builds a model of a minivan. The finished model is exactly the same shape as the original, but smaller. The scale factor is 2 to 9. Find the ratio of the height of the model to the height of the original. So I'm going to draw a perfect minivan. There it is. There's my minivan. Okay. So if that is the original minivan, then the model, well, actually, if that's the model, then the actual minivan is going to be much, much larger. Okay. So if this is my x direction, then this length here is going to be 9/2 times x. If this is my y direction, then this length here is going to be 9/2 times y. And if this is my z direction, then this is going to be 9/2 z. So find the ratio of the height of the model and the height of the original. So if the original height is 2, which way does it want me? Write these ratios in the form mn. And it doesn't tell me which one's m and which one's n. I think it's going to be 9 to 2. Okay, what about the surface area? Well, this area here is just x times y, and then all of the other areas are going to be two-dimensional. So this area here is going to be 9 over 2y times 9 over 2x. So the area is going to have a ratio of 81 over 4. 9 over 2 times 9 over 2. So this is going to be 81 over 4. What about the volume? Well, the volume is x times y times z. So over here, it would be 9 over 2x times 9 over 2y times 9 over 2z. So you're going to get 9 to the third. I don't know what that is. And 2 to the third, which is 8. What is 9 to the third? 729. So 729 to 8. Okay. All right. These two cylinders are similar. So this has a radius of 2. This has a radius of 3. So the area of the small one is pi times 2 squared. So that's the small one. The area of the large circle is going to be pi times 3 squared. Okay. So what is the ratio of the areas? So 9 pi divided by 4 pi equals 9 over 4. That is the ratio of the areas. But remember, the areas are two-dimensional. So the ratio of the areas is actually the ratio times itself, also known as r squared. So we need to take the square root, which is 1.5. That means that the big cylinder is 1.5 times as large as the small cylinder. So the height is going to be 3 over 2. The surface area is going to be 9 over 4. And the volume is going to be 27 over 8. R squared, and r to the third. Okay. Two containers are used to hold liquid. These containers have exactly the same shape. The first container has a height of 20. So the big H is 20 meters, and its volume is 192 meters cubed. The second container, little h, oh, I got that backwards. So little h and little v. Big H is 35 meters. And what is the big volume? Well, 35 over 20 simplifies down to 7 over 4. So that is 7 over 4 in this direction, 7 over 4 in that direction, and 7 over 4 in that direction. So 7 to the third over 4 to the third is, I think that's 243. So 243 over 16. And that's when we go in this direction. So I'm going to take this and multiply it by that, and that will give me the volume. All right, that's it. Get to work.